Okay, Assalamualaikum warahmatullahi wabarakatuh and greetings to all. Okay, my name is Abdul Mahimi bin Muhammad Shafi. I will present about a smart IoT based misting system of capsicum protein seed germination for sustainable agriculture. Okay, so this is my presentation outline. Start from introduction, objective, methodology, result and discussion, and lastly is my references. Okay, for my introduction, so the genus of capsicum species or chili pepper contain about 25 to 30 species. Okay, the chili plants is commonly known as a vegetable crop with multiple uses of traditional medicine and in culinary mainly due to its pungency. The chili is known to have a low calories, high potassium, and rich in vitamin A and vitamin C. Unlike other vegetable, chili, however, is a high-value vegetable crop, okay, that cultivate in Malaysia based on the average price of vegetables published by Federal Agriculture Marketing Authority. Okay, the market demand for chili product is increased along with the community growing demands. So this can be seen from the statistical data from Department of Agriculture on the chili hectarage from 2018 to 2020, which keep increasing from 2,390.1 hectare to 2,967.2 hectare in 2020. However, current level of chili self-sufficiency in Malaysia is only 30.8%, okay, during 2019, so which contribute significantly to the high food import costs and increasing the national food security concern. Okay, in response, uh, Ministry of Agriculture and Food Industry, MAFI, has established National Agro-Food Policy 2.0 to address this concern by guiding the country's agro-food sector to be more sustainable, resilient, and high-tech. On the one of the strategies of to comply with the National Agro-Food Policy 2.0 is by using modernization and smart agriculture. Okay, following the Industrial Revolution 4.0, agriculture activities in the field are shifted from traditional method to various technology that can accelerate the planting and management process in the field while ensuring the higher crop quality and yield. Okay, utilizing the technology has also helped to mitigate the labor shortage in the industry. It also been determined that this application of the technology is in the field can positively affect the sustainable development goal, specifically the sustainability of agriculture and food production. In next, conventional and modern methods are used to cultivate chili plant, especially in a crop irrigation system. So these include the use of micro irrigation system and overhead sprinkler system. So the modern type of irrigation method, however, only irrigates the plant at a specific period and specific times. Most of the farmers use water loss data such as the temperature, humidity, wind speed, and net solar radiation as input to their irrigation control system and for water saving purpose. So these irrigation systems are controlled by timers that schedule based on the previous data and farmers' experience instead of real-time data. However, this irrigation system can be improved by introducing a precision irrigation system that not only can reduce the farmer management costs, but also increase the plant growth. Yeah, IoT, the Internet of Things, is a system that interrelated of computing device, machine, and humans that provide the ability to send the data over a network without requiring human to computer interaction. Hence, IoT can control the irrigation system to supply to crop at a specific time, depending on the real-time soil moisture content. The previous research has come with several semi-automated and fully automated irrigation system to reduce water waste and increase the crop yield using timer, controller, switches, and that switches and that is incorporated with Internet of Things. So the main objective of this paper is to study the optimal moisture content with complete germination of capsicum protection seed on day 7 after sowing using IoT technology. Okay, so this is my methodology, consists of seed preparation, design of experiment, hardware setup, and software setup. Okay, so for the seed preparation, the seeds used come from the same producer, and 50 seeds are soaked with water for 24 hours to avoid the seed dormancy problem. Okay, beside that, we can distinguish between the damaged and a healthy seed by observing the behavior of the seed. So the floating usually is damaged and unhealthy, whereas the seed that are sunk considered as good and healthy seed. Okay, for this study, only 30 seeds are selected to be germinated. Okay, for hardware setup, okay, the seed are placed under a rain shelter in a rectangular container to avoid the external interference. Okay, burnt rice husk was used as a planting medium, and it was also dried truly before the experiment to avoid any disturbance at the initial reading of the soil moisture. Okay, next we're moving to hardware setup. So figure 3 shows the misting system setup from the side and top view. Okay, so small round holes have been drilled at the bottom of the container to prevent the water stagnation. So the spacing between the seeds also sown with approximately equal spacing from each other. Okay, each misting nozzle was placed at the top of the test material with the distance of 30 centimeter from the surface, and a total of 6 misting nozzles were installed to maintain the soil moisture reading immediately. Okay, the misting operation is run using 12-volt direct current 6 ampere different pump, and the water sources used for each stage of treatment is tap water, which is not mixed with other fertilizer or any substance. So the seeds and the soil moisture are planted in the burnt rice husk with the same depth of 1 inch and then cover up after the sowing process. Okay, for the design of an experiment, 3 treatments have been used in this study, which is T1, T2, and T3, which the moisture content or moisture percentage are set to 20, 40, and 60% respectively. Okay, the germination operation is run and observation is made every day to observe the seed germination up to 7 days after sowing. Okay, the seed is deemed to have germinated once the epicotyle tip is elongated to 2 millimeter from the seed coat is seen. Okay, the design of experiment used in this research is a complete randomized design with one factor. Okay, the automation for software setup, the automation of the misting system is controlled by using ESP32 microcontroller for IoT provision through Wi-Fi connection. Okay, the measurement of the soil moisture is taken by using HD38 analog soil moisture sensor. Okay, so this soil moisture sensor is calibrated in the first place to obtain the accurate result. Okay, the pump is triggered to keep the moisture percentage at the threshold value whenever the measurement is below the threshold value. Okay, and then the pump is then triggered off when the measurement exceeds the threshold percentage. The automation of the diaphragm pump is controlled by using a 5-volt direct current 2-channel relay. Okay, the coding is written and uploaded to the ESP32 microcontroller through Arduino Integrated Development Environment IDE. Okay, the program is also integrated with the Blink IoT platform for data monitoring and acquisition, which can be done through either a smart device or computer. Okay, for result and discussion. Okay, the result is analyzed by performing statistical analysis using ANOVA and a comparison of means by using the key test. Okay, the result obtained throughout the experiment are tabulated as shown in table 2. Okay, treatment 1, treatment 2, treatment 3 show a significant difference in successfully germinated seed. Okay, the moisture percentage of 60% T3, treatment 3, has the highest germination rate, whereas the lowest germination rate is observed with the setting of 20% of soil moisture percentage. Okay, however, there is no germination of seed observed from day 1 to day 4 for all treatment. Okay, the seed, however, start to germinate on day 5 for treatment 2 and treatment 3, whereas there is still no germination of seed in treatment 1. Okay. On the other hand, the increment in germination rate can be clearly seen on day 6 and day 7 for treatment 2 and treatment 3. Seedling in treatment 1 and treatment 2 seem to experience a water deficit for both treatment, as all the seed does not emerge uniformly within 7 days after sowing. Okay, water deficit also positively affect the growth of epicotyle and increase seed dormancy in treatment 1 and treatment 2. Okay, the result also show that there was a significant difference in germination rate among the treatment means. The treatment 3 was found to be the most significant among other treatment with 98.89% rate of germination, whereas treatment 1 was found to be the least significant rate of germination compared to other treatment with 4.44% of germination rate. Okay, figure 5 shows the slope of regression model represent the speed of germination rate over time, which is in day. Okay, the highest germination speed was found at 12.98% per day for treatment 3. Okay, and 7.82% per day for treatment 2, 0.57% per day for treatment 1. A moderate relationship between germination rate and germination period was shown by all treatment by the value of R square. For treatment 1 is 0.6154, treatment 2 0.6444, and treatment 3 0.6453. Okay, for my conclusion, the result of this research show that capsicum frutescens seed in 60% moisture treatment, which is in treatment 3, shows the highest adaptive characteristic in the germination stage, with all the seed germinated on day 7. Okay, treatment 3 was also to break the dormancy of chili seed by exhibiting considerably more germination than other treatment. Chili seed treated with lower moisture percentage show lower seed germination. Hence, it is recommended to maintain the moisture content at 60% of moisture, as it gives a full seed germination within 7 days after sowing. Furthermore, it is important in producing higher germinability and seedling growth performance in chili production, as it positively affects the sustainable in agriculture and food production. Okay, then this is my references. Okay, thank you for lending your ears. Assalamualaikum warahmatullahi wabarakatuh.